All right, so now we're going to talk about 7.4, which is linear inequalities in two variables. We're also going to talk about systems of linear inequalities. All right, so first of all, in case you forgot, which is fine, because I don't know if we've talked about it in this. I think we may have, but we haven't talked about inequalities much. But an inequality is an expression with less than or equal to, greater than or equal to. Most importantly, it's just not an expression that has equals. That would be an equation. Okay? So, let's move on. We have to discuss a couple of definitions because I'm gonna be using some terms, and rather than just talk about them blindly, I just want to go ahead and tell you what those are going to be. All right, so a half plane and the graph of a linear inequality. So a half plane is what happens when we graph a linear inequality. So let me begin by just showing you what a graph of an linear inequality might look like. So I'm going to just put a graph here. I will tell you what it is in case you're curious, but we won't. For this particular example, I'm not going to derive how I found it. So let me just draw a line. Okay, this is the line x plus y equals 3, x plus y. But instead of equals 3, I'm going to say is less than or equal to 3, so that I'm introducing you to an inequality. Okay, so my intercepts here, if it was an equation, would be 3 and 3. And then the half plane is the set of points on one side of a line. Now I'm graphing x plus y is less than or equal to 3. Okay, the half plane is basically what happens is, so you can shade that however you want, as creative as you'd like. When I draw the line x plus y equals 3, it makes two half planes. This is a half plane, this is a half plane. Now the graph of a linear inequality is the half plane that satisfies the statement. Okay? So each of these are half planes. But the graph of the linear inequality is this side of the half plane. So we draw the line, the linear equation, and then we shade where it is satisfied. And that's it. All right, and here is how we do it. So I'm going to do an example here in a minute, but first I want to just tell you what the plan is going to be. So the first thing I'm going to do is just write down an equation. So if we have an inequality, I'm going to just write it down as if it was an equation. Okay? So I would think of this previous guy as x plus y equals 3 without the less than. Okay, so first replace the inequality with the symbol of an equal sign, and then graph it using intercepts if possible. If the original inequality is less than or equal to or greater than or equal to, we're going to use a solid line. If it was less than or greater than without the equals, we use a dotted line. Okay, so what this means is, if it includes the equal sign, that it means it includes the points on the line. If it does not include the equal sign, it means it doesn't include those. That's it. Right, how do we do that? Then we choose a test point on the line. A test point that is not on the line. It only works if the point is not on the line. Substitute the coordinates of that test point into the original inequality. Okay. If it makes a true statement, that's where we're going to shade. Okay, in this example, I probably would have chosen 0, 0 to be my test point. Okay. 0, 0 satisfies this statement. 0 is less than 3. 0 is less than or equal to 3. It's not equal, it's less than. So it's one of those. So our test point, if 0, 0 is available, we use that. Okay. So when we do our test point, if it's true, that's where we shade. If we do our test point and it's false, we shade elsewhere. That's all there is to it. So write those down. If you need to pause the video to do it, you can. I'm going to talk through them as I work through our example. Okay, so here's our example. Graph the following linear inequality. Okay, so this is a linear because our x and y is raised to the first power. And then it's an inequality because it's not an equal sign. So here's the way we do this. We first think about this as 4x minus 6y equals 24. Okay? And we're going to graph this using intercepts if possible. So graph the equation using the intercepts. So our x and y intercepts. So by now you probably can do this a lot faster, but for the x-intercept, I'm going to let y equals 0 solve for x. Okay. So 4x minus 6 times 0 equals 24. 6 times 0 is 0, so 4x minus 0 is 24. 4x minus 0 is 4x. 4x equals 24. Therefore, x, if you divide both sides by 4, you get 6. Okay. So our x-intercept is 6. 1, 2, 3, 4, 5. Well, my graph is a little too short, so I added it right there. So this is my point, 6, 0. Okay, right on this. All right. You could make a note that that is the point 6, 0. But since we're talking about intercepts, you just put x equals 6, and that's it. Okay. Now I need the y-intercept, so I'll do that right here. The y-intercept, let x be 0, solve for y. Okay. Again, I'm looking at the equation first. 4 times 0 minus 6y is 24. 4 times 0 is 0. Minus 6y is 24. 0 minus 6y is minus 6y equals 24. We divide both sides by this minus 6. We get y equals minus 4. Okay? So if y is minus 4, that's 1, 2, 3, 4. That's right here. That's the point 0 minus 4. Okay? That's the point 0 minus 4. Now, we look back at the original. Okay? Notice, since this is less than, that tells me we're going to use a dotted line. Okay, so I connect these using a dotted line. So it's a light dashed dotted line. It means we're not including it, but that's what we got to graph. Now we got to test the point. Okay, so let's think back So since I'm scrolling down here, let's see. Since my inequality is 4x minus 6y is less than 24, I need to test the point that is not on the graph. So test 0, 0. 0, 0. I will always test 0, 0 because that is the easiest thing to test. And I'm allowed to do it as long as the graph doesn't cross through the origin. And it's usually pretty easy to see if it does. If the graph crosses through the origin, just scoot over, do something else, like minus 1, 0, or 1, 0, 0, 1. Just do something kind of easy, include a 0 if possible. Okay. All right, so let's do that. What do I mean by testing 0, 0? Well, 4x minus 6y, this means that I'm going to let x be 0, and I'm going to let y be 0. So 4 times 0. What this means is if I substitute 0, 0 in, does it make a true or false statement? Okay, so let's see. 4 times 0 is 0. Minus 0 is less than 24. So the question is 0 less than 24? Okay. So my question, I'm plugging it in, I'm asking, is it true? I get down here, is that true? Of course that's true. True. So, what that means is we're going to shade on the half plane with the test point 0, 0. That's what we're going to do. All right. So I sketched 0, 0. There it is. I'm just going to shade in. Now, on my math lab, you have a paintbrush feature. The graph goes down forever, so it actually includes all of this. All of this. The graph is actually continuing, even though we can't see it. The graph is continuing forever. Of course, your computer only will include so much of the graph, but it does keep on going. Okay. So that is how we solve a linear inequality. All right, so I'm going to tell you one more thing, and then I think we'll probably stop the video. Okay. So I want to discuss graphing horizontal and vertical inequalities. All right. So the first one we're going to talk about is vertical inequalities. So to begin with, remember a vertical line is of the form x equals a. To graph a vertical line inequality, we got two things to think about. One, if x is less than a or x is less than or equal to a, we're going to shade the half plane to the left. Obviously, if it was less than, we put dotted line, less than or equal to solid line. However, if it's greater than a, greater than or equal to a, we shade the half plane to the right. That's it. So let's just look at an example. All right, we got x is less than or equal to 3, minus 3. Because it's a solid line, that means, or a less than or equal to, we're going to use a solid line. Okay. X is less than or equal to minus 3 is a vertical line, 1, 2, 3. through x equals minus 3. And now I'm going to draw a vertical line. All right, so there it is. Less than means I'm shading to the left. All right, that's it. Now we'll look at a horizontal inequality. So horizontal lines have the equation y equals b. To graph a horizontal line inequality, if it's less than b or less than or equal to, we're going to shade below the half plane below. If it's greater than or greater than or equal to, we'll shade the half plane above. All right, so let's knock out a quick example of that. So let's graph y is greater than 2. Since y is greater than 2, we first graph y equals 2. Okay. Because this is dotted, or because it's greater than, that means it's going to be a dotted line. Okay. Since it's greater than, I shade above. There you go. That's all there is to vertical and horizontal inequalities, but I felt like I needed to discuss those. So there you go.